Most of you will have seen one of these before, in the shops or in your classroom or workshop. In fact, they've not been around all that long. These were specially designed in 1964, and we know them as the red handle range. Seems a simple sort of tool, doesn't it? Taken for granted a bit, perhaps. After all, almost everyone in the world will use one of these at some time in their life. And it's pretty amazing the number of uses and misuses it can be put to.
Take woodwork, for instance. A good craftsman will take care to use a screwdriver that's right for the job. In this case, one that exactly fits the screw head that has to be driven into the wood. If the blade is the wrong size, it will either damage the screw as it turns, or you'll end up chewing the head to bits. And even if you manage to get the screw in with the wrong tool, you'll certainly have a hell of a job getting it out again. Besides, it will look a mess, and you don't want to be accused of bad workmanship. To do the job properly, you first of all need to drill a hole of the right diameter to take the threaded part of the screw. Then, the hole needs to be drilled out a little bigger at the top to allow the shank, or the thicker part of the screw, to fit. Lastly, a countersink bit makes sure the head of the screw can be driven easily below the surface of the wood. All this preparation allows the craftsman to use the screwdriver in the correct way. So we're into ergonomics. How the tool will be used, the relationship between the tool and the user. And when driving the screw in, try and think of the screw as part of the screwdriver blade until the screw is right in. All pretty simple stuff you may think, but you'd be surprised how many jobs are botched by using the wrong driver or screw. Take a look at how this craftsman uses the screwdriver to do this particular job. It may occur to you that he's right-handed, so he'll use his hands in a certain way. He's made a pilot hole in the wood, and the tip of the driver fits the slot in the top of the screw. In this case, the screw is a number 10 2-inch countersunk. More about that in a minute. Let's watch in detail the actions he has to make to drive the screw into the wood. He uses his left hand to steady the tip of the blade and his right hand to turn the handle. Have you ever thought how natural a movement that is? You can all do it, I'm sure, but who taught you? It probably came naturally to you. Just watch the action of the right hand. Every time the handle is turned, the hand comes off for a split second before another turn or twist is made. The shape of the handle, therefore, is very important. It's got to be comfortable, the right size and shape. In days gone by, craftsmen used to make their own handles, specially to fit their hands. And if you were a carpenter's apprentice, you'd probably do the same. That was before the days of the plastic handle. This is called a cabinet screwdriver, and as you can see, the handle is made of wood. They're still made, even though they're expensive, perhaps because there are craftsmen who find that sort of shape and material suits their hand. In other words, they like to have a natural feel for the job, to be part of it. It's natural, isn't it? And while we're talking about natural things, no one person invented the screw or thread or spiral. It just evolved.
Today, there are literally hundreds of different uses for threads and screws, and many different ways of turning them. But since we're on the subject of screwdrivers, let's show you some of the wood screws in use. Firstly, how do we describe the size of the screw we want to use? Well, to make things easier, I've picked out a big one. This is a number 10 gauge, 2-inch, countersunk brass screw. And its size is measured by its length from the head to the tip, and its gauge, which is the diameter of the shank, this section here. And as I said, this is a number 10 gauge, and its length is 2 inches, or 50 millimeters. A screw that's 3 inches long can still have a number 10 gauge, provided the diameter of the shank is the same. And the same goes for a 1-inch screw or a 1/2 inch. Then there's the shape of the head. This is a countersunk head, which means it should be driven below the level of the surface of the wood, like this. This is the round head screw, which stays above the surface of the wood. This is often used for fixing things to wood. This is what's called the raised head screw, often used for fixing things like doorknobs or ornamental fixtures. A more recent invention is the superdrive head. This can be very useful if you want to balance it on the end of a screwdriver like this and get into difficult places. They're used a lot in the motor industry. So, there are many different types of screws, as well as many different sizes, gauges, and lengths. There are also many different ways of turning screws, and in the case of screwdrivers, many different shapes and sizes in the red handle range. There are also many other different types of screwdrivers, each designed for a specific job.
Take a look at this little screwdriver, used by instrument makers. Notice how I hold it. Because it is so small, I put my finger on the top and turn it with my finger and thumb. Watch this action and then compare it to driving a great big screw-in.
Craftsmen tend to develop preferences for different types of tools. They become used to something. Well, everyone works better that way, especially if you're doing the job for yourself. If you've got the right tool for any job, you're halfway there, aren't you? Car mechanics like this one. Do you know why? Because you can get a good grip on it when you've got greasy fingers. Until about 200 years ago, a screwdriver would have been a rare tool in a carpenter's shop, and then it would have been made by a blacksmith. In 1964, this screwdriver was designed together with a whole matching range of drivers, from the very small to the biggest you ever need. In the trade, they're known as the 5000 range, and when you buy one in a tool shop or an ironmonger's, you can see its number and size stamped on the head. This is a 5008, and as you can see, it's 75 millimeters long, and the tip is 5 millimeters wide. And look at the way it fits in my hand. Not bad, eh? Just holding it makes the job feel easier before you start. And that's ergonomics too. But before I tell you how it's made, let's meet the man who designed it, and let him tell you himself how he arrived at this shape. His name is David Carter, and he's designed all kinds of tools. And just like any other designer, he always starts with a blank sheet of paper.
We first of all produced a lot of sketches. These were done quite roughly initially, but then we got to very detailed drawings, and these were then made up in model form in our workshop. We made them in wood or in plastic materials. And we then had to understand the processes of production, the techniques of making in mass production in large quantities, and how, for instance, the shaft was fitted to the handle. And you can see on this particular one where the shaft has got some little ribs along the side of it, so that when you push it into the handle, it doesn't rotate when you apply the twisting force with your hand. It's necessary also to know about the people who use the tool and where they use it and how big their hands are and what sort of environment they're working in. It's a question really of relating the brain to the eye and the muscle to the job which has to be done.
And this is exactly where the 5000 range of red handle screwdrivers are made. The steel rods, about 5 metres long, come from the steel works and are first cut into the required lengths.
These rods are fed into this cold forging press. The shape of the screwdriver blade is then pressed cold by a pressure of 200 tons. Have a look at this and see what happens. In fact, each rod is pressed 4 times, and you can just see by the time the last press comes down, the blade is already the right shape.
Another way of changing the shape of the rod is by using a hot forging press. The rods are heated in electric coils to 800 degrees centigrade. It takes a few seconds only for the tips to get red hot, not even long enough for the heat to be conducted to the end. The rods are then pressed, or rather roughly flattened, before being taken to another machine which cuts and trims them into shape.
Whichever way they're forged, the blades are then put onto this conveyor belt, which takes them into this furnace, called a hot oil quenched furnace. This process hardens the steel. Well, it's understandable, isn't it? Soft while you bash the living daylights out of the steel, and then hard as it comes nearer to being a tool itself.
Now comes the time when the blade of the screwdriver meets the famous red handle. As you can see, the plastics comes in here in this hopper and is then forced through this screw, with colour added and the heat getting hotter as it reaches the start of the mould. The blades, which have been plated to give an attractive bright look, are then placed in this mould. The top half then comes down onto the bottom half and the plastics is injected into the mould around the blades. So blades and handles become one complete tool.
This machine assembles the handle to the blade in a different way, literally by pushing it on. This handle is the type favoured by car mechanics with greasy hands that I mentioned earlier. They're made by extruding plastics through a die. Well, here's the handle, here's the blade, watch. It's easy, isn't it? Just apply the force of 1 ton in the right place and you've got to get your own way.
And this is where the tools are skin wrapped and prepared for the high street shops.
Simple tool, people say. Good job it's not more complicated, or you'd be sitting there all day.